Okay, so section 5 is on limits involving infinity. So basically that means we're going to talk about horizontal and both vertical asymptotes. So some of them are going to be like limit as x goes to 2, but if that's a vertical asymptote, maybe it goes up to infinity or down to negative infinity. And then some of them will say like the limit as x goes to infinity, and that's going to be like a horizontal asymptote. So it says for this section, we need to do a quick review of horizontal and vertical asymptotes. So I think we kind of did this at the beginning of the year. Didn't we talk about horizontal and vertical? So this should be pretty easy. So number 1, so it says determine all vertical asymptotes of the graph of each function. So vertical asymptotes, if you remember, come from the denominator. So you set your denominator equal to 0. So you would have x equals 2. So that's our vertical asymptote. All right, so the next one, what do you guys think the vertical asymptotes are? All right, so when we set our denominator equal to 0, what 2 numbers do we get? Yeah, plus or minus 3, right? So you can factor if you want to, or you could subtract or add the 9 over and then take the square root. Just make sure you do have plus or minus 3. So that one would have 2. All right, and then the next one, tangent of x. So tangent is sine divided by cosine. So basically we're asking where is cosine of x equal to 0. So think about your unit circle. Cosine of x is equal to 0 at pi over 2, 3 pi over 2. You'd add again. So 5 pi over 2, 7 pi over 2, and so on. So do you guys remember how we wrote this like in pre-calc? So we write one of the answers. So one of the answers is pi over 2. Yeah, and we want to add close, not 2 pi though, we want to do 1 pi. So it's every rotation of half the circle, you get another answer, right? So it's going to be plus pi k. And you could be, very precise and say where k is an integer. But it's kind of implied that k is an integer. We know what pi k means. So I think you guys used pi n last year in pre-calc. It doesn't matter. I do pi k. I'm weird. All right. So it says find all vertical asymptotes of the graph and describe/sketch the graph. Okay, so if we factor the numerator and the denominator factors easily. It's x plus 3 and x minus 3. But the numerator factors into x minus 3, right? And then x plus 4. So what happens is the x minus 3's go away. So who remembers what that means? Yeah, there's a hole. So we're going to have a hole at x equals 3. Okay. That's called a removable discontinuity. We'll be talking about that throughout this chapter. All right, so we're left with x plus 4 over x plus 3. So that's what we're actually going to graph. So every question I ask is going to use this, so x plus 4 over x plus 3, it's going to use this simplified function, okay? So when I ask you where are the vertical asymptotes, we only use that simplified function, yeah?
For D on number 1, wouldn't it just be x equals 3 then?
No, because x squared plus 9 is prime, it doesn't factor any. Do you remember that? So if you tried like x plus 3 times x plus 3, right? When you FOIL it out, you get your x squared and you get your 9, but you'd also have a plus 6x in the middle. Is that what you're thinking? Yeah, but good idea. All right, so our vertical asymptote then is going to be at x equals negative 3. And our horizontal asymptote, so I always say, there's a shortcut. So our shortcut is to look for our largest degrees. So our largest degree on the numerator is x the first, and on the denominator is also x the first. So do you guys remember how to do that? So our horizontal asymptote is y equals 1, because it was x divided by x. We can ignore all those other things, because basically a horizontal asymptote is a limit as we go to infinity. So we're plugging in huge numbers. So imagine plugging in like 1 billion. 1 billion plus 4 divided by 1 billion plus 3 is really pretty much 1, right? And the bigger we get, the closer it gets to 1. All right, so if we're doing a little rough sketch here, we'd have a vertical asymptote at negative 3, a horizontal asymptote at 1, And we know we're going to have a hole somewhere at 3. So you can plug in points. I usually plug in points that are next to the vertical asymptote. So I would plug in like -2, and I'd plug in -4 to see what's happening. And I plug them into this simplified function. So when I plug in -4, I actually get 0. So I have a point there. And when I plug in -2, what do I get? So 2 over 1, so 2. So that's up here. Does that make sense? So when we draw it in, it goes along the vertical and then along the horizontal. And this one goes along the vertical, or along the horizontal and then along the vertical. And the very last step, 1, 2, 3, draw a hole wherever 3 matched up with the graph. So that's our graph. You guys kind of remember that? I don't think it's like totally crucial that you remember how to graph it, but it is crucial that you like know how to find each individual thing. Do you know how to find a horizontal? Do you know how to find a vertical? Do you know how to find a hole? Okay. So number 3, so it says find the limit as x goes to 4 from the right and limit as x goes to 4 from the left of x squared minus 9x over x minus 4. So let's see what the graph looks like. So we can use our graphing calculator. Might be easier if I use Desmos, but I'll use the graphing calculator for you guys. So we go to y equals, and we put in x squared minus 9x divided by x minus 4. So do you guys see why our limit as x goes to 4 is going to be interesting to us? Because we have x minus 4 on the denominator, right? So we have a vertical asymptote at 4. So when we hit graph, it's always so hard to see the screen. We have kind of a slant asymptote going on. Do you guys remember what makes it a slant asymptote? When it's 1 degree more on top. So we have a slant asymptote going on, but then there's a vertical asymptote here at 4. So when you have a slant asymptote, there's no horizontal asymptote. So it's like right here. And it's going up along there, and then it's going somewhere along here. Okay, so what do we think the limit as we go towards 4 from the right is? What would you guys say? Negative infinity, do you guys agree? Negative infinity, you guys are quiet today. 4 from the left? Positive infinity, right? So if I talked about the limit as x went to 4 in general, we would write d and e, doesn't exist, okay? Now infinity and negative infinity, like I was saying before, they actually don't exist as well. So the AP test, if it's a multiple choice question, they might have does not exist. So just know that that's not a number. It doesn't go to a certain number. Limits always go to numbers, okay? All right. Okay, so the next thing, it says we found vertical asymptotes by setting denominators equal to 0, but horizontal asymptotes are the y values our graph approaches on the ends. So in other words, as we approach infinity or negative infinity. So most of the graphs that you see will have only one horizontal asymptote. So that's when you have like a polynomial divided by a polynomial. But we are occasionally going to see ones in calculus where we have 2 horizontal asymptotes, and that's those ones that have like the square root of x squared somewhere, okay? So it says the line y equals L is called a horizontal asymptote if the limit as x goes to infinity is equal to L, or the limit as x goes to negative infinity is equal to L. I didn't say equals L here. All right, so there is a shortcut to find the horizontal asymptotes. When you have polynomial numerators and denominators, we just look for our largest degree. So like on number 1, our largest degree is x cubed. So we're like, oh, I have 1x cubed divided, well, hang on. I said long way here, didn't I? We'll do the shortcut over here. So we have 1x cubed divided by 2x cubed. So we know it should equal 1/2. So I've showed you that, guys, this shortcut for a very long time. You've known this since like algebra 2. But in algebra 2, you never learn like why this works. Okay, so here's what's happening behind this. It's basically a limit problem where our largest degree was x cubed. So we're going to take every single term and divide out by x cubed. So we're dividing our numerator and our denominator by x cubed. And we start reducing, so we're like, okay, this is equal to the limit as x goes to infinity. So we have 1 plus 8 over x squared over 2 minus 1 over x plus 7 over x cubed. Okay. Lots of writing. Angel, you with me? So we know with our limit laws that we can bring this limit into the numerator, we can bring it into the denominator, we can bring it into each individual thing. So we're finding the limit as x goes to infinity of each of these 5 pieces. Okay, so imagine you have a really huge number, 13 trillion, huge number, even bigger, a Google. I don't know, so we're plugging in x goes to a Google, and we plug in for x. What's happening to 8 over x squared then? If we're plugging in a really huge number. It what? Yeah, it goes to 0, right? All right, what about the 1 over x and the 7 over x cubed? They go to 0 as well, right? They're insignificant now because we're plugging in such a huge number for their denominators that 2 divided by this gigantic number is really just 0, right? So that means that our only numbers left are 1 over 2. Does that make sense why this works? Okay. So that's where our shortcut method comes from. So obviously we don't want to write this out every single time, so you guys can use the shortcut method. So on this next one, so our largest degree is x squared, and our largest degree on the bottom is negative x. So we got something weird going on. So it works out to be like the same as negative x. So what happens is I plug in a really big thing for x. What do I get? It goes to negative infinity, right? So all of this is equal to, I don't know how to write this, equals negative infinity. Okay, so is there a horizontal asymptote then? No, because the end behavior as you go to the right side of your graph, it's going downwards like that. So there's no horizontal asymptote. All right, so this next one, so we have x squared over 4x. Which ends up being x divided by 4. So what do we get when we go to negative infinity? Negative infinity, right? So people are always like, oh, but we divided by 4. Like infinity divided by 4 is still infinity. I know, it's really weird, isn't it? Infinity divided by infinity. What do you guys think infinity divided by infinity is? We don't know. I know, think about if it was x squared over x. And we took the limit as x went to infinity. That's infinity divided by infinity, right? That goes to infinity. This one goes to 0. This one, if I had x squared over x squared, that goes to 1. So you have different levels of infinity. Isn't that very confusing? Calculus, so weird, blowing your mind. All right, so number 4. So find the horizontal asymptotes or the end behavior for the following functions. So I have a homework assignment where I basically ask for you to draw like the ends in. So like this one on the end, as you go to infinity, it goes towards 1/2. So like you would have something like that on the end, right? And the next two were ones where there was no horizontal asymptote. So I'd have you just draw that one side, like just so I can visualize. Do they know where it is? All right, so number 4. So find the horizontal asymptotes or end behavior for the following functions. You will need to find the limit as x goes to both positive and negative infinity. So we're going to do the limit as x goes to infinity of our g of x. And we're going to do the limit as x goes to negative infinity as well. So like I said, most of the time, you really just need to think about one. You don't need to do both. All right, so on this one, since we have the square root of 2x squared, this function gets approximated, and we only worry about those largest powers. So it's going to be 2, the square root of 2, square root of x squared. Let me write that like this, which is the square root of 2 times the absolute value of x. So we talked about that just the other day. Do you guys remember? The square root of x squared is absolute value of x. You guys learned that in algebra 2, and then everybody forgets it. Because a lot of times we just assume x is positive. All right, so as I plug in a really big positive number, so even just thinking about 100 and negative 100, you'll be good to go. So if I plug in 100 into here. I get the square root of 2 times 100 divided by 300. Okay, so the 100 and 100 go away. So our answer is root 2 divided by 3. But the next one, if I plug in negative 100, what's weird about this one? What does it become? Negative root 2 over 3. Because the top is positive because of the absolute value and the bottom is negative. Okay? So this is one that has two horizontal asymptotes. So basically on the left side, we would be going towards that number, and on the right side, we'd be going towards the positive version of that number. Okay? And you can graph it if you want to see what it looks like. Maybe I'll pull up Desmos. I'm going to have people's pictures. Okay, so if I pull up Desmos, 2x squared here's what it looks like. You guys see? So on this side, we have a horizontal asymptote getting closer to that one number. And on this side, we have a horizontal asymptote getting closer to the other version. Okay, so that's what's happening on that graph. All right, so on this one, it's the same idea. So we approximate it, and we're like, oh, I got 5x over square root of 9 is 3, absolute value of x. So as I do the limit as x goes to infinity of my f of x function, as I plug in a really big positive number, I get 5/3. As I plug in a really big negative number, I get negative 5/3. Okay, so I have 2 again. So look for those ones that have like the square root of x squared. All right, so the next one. So if g of x is equal to the square root of 4x squared minus x all over 6 minus x. So again, kind of approximate it. It's 2 absolute value of x over negative x. So as I go to infinity, plug in a really big positive number, what do we get this time? So think about plugging in 100. You'd have 200 on top over negative 100. Negative 2. Mm-hmm. So how about as I go to negative infinity? I'd have negative 100 on the bottom. So positive 100. So that would go to 2. Okay? All right, so how about this one? So this one gets approximated by negative 2x to the 5th over x to the 4th. Those were the 2 largest degrees. So I know there's no horizontal asymptote because it doesn't match up on the bottom. So previously, like in Algebra 2, we would write in a 0x to the 5th, if you remember. Right, so we're not going to do that. We're just going to look at each individual largest degree. So I get negative 2x. So as I plug in infinity, I get negative infinity. And as I go to negative infinity, I go to positive infinity. So that means the ends are like on the left as I go, x values go negative, y values go positive. It looks like that. Make sense? Easy enough? All right, so find the limit as x goes to 0 of 1 over x squared. Do you guys all know what 1 over x squared looks like? This is a good graph to have, like to know in the back of your head. So it would be a good like flashcard graph. There's lots of calculus graphs that are important. So this one's important. It looks like this. So it says find the limit as x goes to 0 of 1 over x squared. So what do we write? As we go from the left and right, it goes to infinity, right? So it says to indicate this type of behavior, we say that the limit as x goes to 0 of 1 over x squared equals infinity. So this indicates that from both the left and the right, our function gets larger as our x gets closer and closer to 0. However, since it's unbounded, right, since going to infinity, it still does not exist. So like I said, on the AP exam, you'll have different choices. So the definition of an infinite limit basically says that the closer you get to a certain number, your y value just gets out of control big, okay, or negative infinity. So it gets larger and larger and larger. It increases without bound, we sometimes say. All right, so similar definitions hold for right and left-handed limits. So just knowing like what each of these looks like. So I think you guys are good here. Yeah, Kyle?
Maybe that
You wouldn't have both. It would just have one, but yeah. That would be really tricky. Hopefully they don't. All right, so as you go towards 2, this is basically like the graph of 1 over x, only it's been shifted to the right 2, and there's been a vertical stretch. So it's looking like this. Okay, and you could try one point on the left and the right of that asymptote, and you would see that. So as I go towards 2, what do you think we write? Yeah, it does not exist because the left and right don't go to the same thing. But as I go towards 2 from the right, I would say infinity. And as I go from 2 towards the left, I would say negative infinity.
Then on the AP test, it would just be D.
It could be either one. Yeah, they could put infinity or negative or does not exist. Yeah, it's very confusing, isn't it? They're mean. They're very tricky. All right, so sketch a graph of a function with the following characteristics. So as I go towards 3 from the right, I go towards infinity. So we're going this way. As I go towards negative 2, just in general, I go towards negative infinity. So both sides of that are going to be going towards negative infinity. So I'm just drawing a little piece of the curve in each location. So down here, and then from the right was up here. Then it says 3 from the left goes towards negative infinity. The limit as x goes to infinity. So think about where that is on our graph. Where is that? Far right side, right? Way over here. So as x gets bigger and bigger and bigger and bigger. So way over there. Our y value gets closer to 3. So we're up here. 1, 2, 3. So we have some kind of horizontal asymptote. So let's put it on the same side as the other one. It doesn't really matter. And as we go to negative infinity, we're also getting closer to 3. So let's put it on the same side over here. Okay, can we fill in the rest of it? So we're going to do connect those two, connect these two, connect these two. These would all have those same characteristics. Now you can have strange things happen with horizontal asymptotes. So sometimes, I drew mine, like I drew this one above the axis, or below the axis, or dang it, below the horizontal asymptote. I could have drawn it above. Have you seen graphs like that where it goes up and then comes back down? Like that can happen. You can cross a horizontal asymptote, just not as you're way out in infinity. So you can have strange things happen, but we'll just go ahead and do it here, here, and here. All right. The middle one can, yeah. You could have like a cubic function. It doesn't usually cross and then come back down though. All right, so the limit as x goes to 3. Okay, this is going to look like 1 over x squared, only it's been shifted to the right 3. Oops. So if you remember what 1 over x squared looks like, we just did it. It looks like this. So as we get closer to 3, I would say this goes to infinity. And then this one is shifted to the left 2. It looks kind of like 1 over x squared, only do you guys see this one has a reflection over the axis? So it's going to look like this. I always have trouble with these. Kind of like the 1 over x is flipping. I have to think about it. Which one's right? So then this one would go to D and E. So it doesn't exist. So from the right, it goes to negative infinity. From the left, it goes to infinity. So we just say D and E. All right.